This is video 3 on rational expressions, and we're going to look at adding and subtracting rational expressions. So we did multiplying and dividing and reducing rational expressions. So here we're going to do addition and subtraction. So remember, anytime you're adding two fractions, you need the same denominator. That's key. Let's just start off with a simple problem. Let's start off with 3 over y squared plus 11 over y squared. So thankfully in this problem we have the same denominator, right? We have y squared as the common denominator. So to complete this, we're going to keep the common denominator of y squared. And so this is going to become one fraction where you have y squared on bottom, the common denominator, and on top you're going to take the numerators, 3 and 11, and add them together, right? So you're going to have 3 plus 11 on top. And then we just simplify the top. We have to make sure we simplify that. 3 plus 11 is 14, so we get 14 over y squared for our answer. Now that can't be reduced, we just leave it as 14 over y squared. So quite simple when you have simply a common denominator. Okay, here's a number 2. Number 2, it looks like we have 2 over 15 a b squared, and then that's added to 3 over 10b. So here we're trying to add two fractions, and the denominators are quite different. If you look at the first denominator here, the first denominator is 15ab squared, and the second denominator is 10b. So remember, you want a common denominator, a least common denominator, if you're adding two fractions. We don't have one, so we're going to have to find this one. So I'm going to show you procedurally. I know some of you can just figure it out like that. Some of you are like, yeah, it's 30ab squared, you're going to say. Some of you. But some of you can just figure it out just by looking at it. So we're going to show you procedurally how to do that. So my first denominator is what? 15ab squared. So what you want to do, you want to break it up into primes. Focus first on the number 15. 15, if you think about 15, doing a factor tree, 3 times 5, right? 3 times 5 gives you 15. 3 is prime, 5 is prime. So the primes that make up 15ab squared are going to be 3 times 5 times a times b to the second power. That's the prime power factorization of our denominator, our blue denominator. Then going to the red denominator, denominator 2, we have what? 10b. So we want to focus on, first of all, 10, factoring that into primes. So we're breaking everything up into primes. 10 factors down into what? 2 times 5. 2 is a prime, 5 is a prime. So we have what? 2 times 5 times b. So b is a prime because you can't factor b down any further. So you have 3 primes, 2, 5, and b. Now remember, when you're finding the LCD, that's what we want to do. We have to take all the primes from the various denominators and multiply them together and take the largest power that shows up. So we have to include 2 multiplied by, we have to include 3. We have to include 5. So we have a 5 that shows up here and a 5 that shows up here. What's the largest power? Well, this is 5 to the 1 power. This is 5 to the 1 power. So just 5 to the 1 power. So just one copy of 5. So far we have 2 times 3 times 5. Also we have an a that shows up here, so we have to include a as a prime. And notice that in both denominators we have a b showing up. The second denominator has just a b, the first denominator has a b to the second power, so we're going to take the larger of the two powers. So since there's a common prime showing up, a common factor here showing up of b, we take the larger of the powers. So 2 times 3 times 5 times 8 times b squared is the LCD. What happens when you multiply 2 times 3 times 5, well, 2 times 3 is 6, times 5 is 30, so you're going to have 30 AB squared. So that is the LCD right there. So we want to turn both of our denominators into 30 AB squared. 30 AB squared. So I'm going to copy down my first fraction. I'm going to ask the important question, what do I have to multiply 15AB squared by to get 30AB squared? We have to multiply that by 2, so I'm going to multiply by 2 on the bottom. And what I do to the top, bottom, I have to do to the top. Right, we have to keep that fraction balanced. We don't want to fundamentally change it. All right, so then I got a plus, and then I got a red fraction, 3 over 10b. And then I have to ask the question, okay, how do I get that bottom 10b in the second fraction to be 30ab squared? What do I have to multiply by? Well, I'm going to have to multiply by 3ab. 3ab. Right? All right. So now we're actually going to do the multiplications in each individual fraction. So the first fraction, we have 2 times 2 on top, it's 4. The first fraction's denominator, we have 15ab squared times 2. That's going to be 30ab squared. All right, then we have the plus sign. Then in the second fraction, we have to multiply what's on top. 3 times 3ab is going to give us 9ab. And then multiply what's on bottom. 10b times 3ab is going to be 30ab squared. So thankfully, notice we have the same denominators here, 30ab squared. So we're going to turn this into a single fraction where the 30ab squared is on bottom. That's the common denominator. And on top, you're going to have 4 plus 9ab. Now, if you could simplify the top, if you could combine like terms in the top, you would do that. But here, can't combine 4 with 9ab, so this is going to be our answer right here. 4 plus 9ab on top, and on bottom 30ab squared. Okay, so that's a number 2 where you had a different denominators. All right, let's do a number 3. Here I'm going to have, let's see, 2 fractions, 6x minus 5 on top of the first, and x minus 3 on the bottom of the first. And then we're going to have a minus sign. And then we're going to have another fraction, 3x plus 4 over x minus 3. This is a little different than the last one. Right? We have a binomial on top, a binomial on bottom, and then a binomial on top and a binomial on bottom. In the previous situation, notice we just had monomials on top and bottom. Now here we have binomials. Now, notice that we have the same denominators, right? We have x minus 3. So since we have x minus 3 as a common denominator, you can just keep that common denominator and make this into one fraction. Where you take your first numerator, 6x minus 5. And then we're going to have this subtraction right here, minus. And then you're going to take your second numerator. And you have to make sure anytime you're doing a minus, this should be in parentheses. So you're going to put the second one in parentheses, 3x plus 4. That's very important to put the second numerator in parentheses. Okay, so after we've put the 2 numerators on top of the fraction, what we're going to do, we're going to simplify the numerator. So I'm going to copy down 6x minus 5. And then I'm going to distribute this negative 1 here. You see this negative here in front? That negative, that's going to become minus 3x minus 4, right? That negative distributes through. And then on the bottom of the fraction, we have x minus 3. Now at this point, what we want to do is combine our like terms. So notice we have 6x. And minus 3x, these are like terms. 6x minus 3x is going to be 3x. And then also we have minus 5 and minus 4. Minus 5 and minus 4 is minus 9. So we have 3x minus 9 on top, and on bottom we have x minus 3. So what I've done, I've cleaned up the top. Now, if possible, sometimes these can be reduced after cleaning up the top. And in this case, we can reduce this fraction. If we factor the top, let's factor the top. Focus on 3x minus 9. How can you factor that? Well, notice there's a GCF of 3, right? 3x and 9 both have a 3 in common. So I'm going to factor out a 3. I'm going to put a pair of parentheses. I'm going to ask the question, what times 3 gives you 3x? Well, x. And then a minus sign. And then what times 3 gives you 9? Well, 3. So we have 3, parentheses x minus 3 is the factorization of 3x minus 9. All right. So underneath that, I'm going to put my denominator of x minus 3. And from here we can cancel out the factors, the common factors of x minus 3. So our final answer here is just going to be 3. Who would have thought, right? No x's in this. Interesting problem. All right, let's do one more. And then we'll pause and then pick up this in another video. Let's say we were to have two fractions, 1 over x minus 3. It's the first fraction. Plus, what's that say there? 3 over x plus 4. So notice that our denominators are binomials. And they're different. So we just can't add the tops together over top of any kind of common denominator here because we don't have a common denominator yet. So we have to find a common denominator. Let's make that our first step. Let's find the LCD. So I'm looking at my first denominator, which is x minus 3. Now x minus 3, this is already prime. It doesn't factor, right? X minus 3, you can't factor it down. It's already prime. Denominator 2 is x plus 4. This guy doesn't factor, right? X plus 4 as an algebraic expression, as a polynomial, it doesn't factor down. This is already prime. It doesn't factor. So we have 2 primes showing up between our denominators. So remember, to find the LCD, you multiply all your primes that show up together and take the largest power if you have like a larger power. So here we're going to take x minus 3. Be nice if this wrote. That's our first prime here, and then x plus 4. That's our second prime. So that's going to be your LCD, x minus 3, x plus 4. So we want to get x minus 3, x plus 4 on the bottoms of these fractions. So I'm going to start with my blue fraction, 1 over x minus 3. And I want to get x minus 3, x plus 4 in the bottom. So to get that, I have to multiply by x plus 4 on bottom. If I do that on bottom, I have to do that on top as well to balance the fraction. So multiplying by x plus 4 over x plus 4. All right, then we go to the plus sign. And then our red fraction, 3 over x plus 4. So for this second fraction, we want to make sure that the denominator is x minus 3, x plus 4. So we have to multiply this guy by x minus 3 on bottom and x minus 3 on top. Again, what you do to the bottom, you have to do to the top to balance the fraction. So now the denominators are the same, right? We have the same denominator. So since the denominators are the same, x minus 3, x plus 4, you just copy it down, the common denominator, and turn this into one fraction. So we're going to take 1 times x plus 4 plus 3 times x minus 3. And from there, we want to clean up the top. What do I mean clean up the top? Well, first of all, you want to distribute 1, and then you want to distribute 3, and then you want to combine your like terms. So first of all, I'm going to distribute this 1. I'm going to do 1 times x is x. 1 times 4 is 4. Then we're going to do 3 times x is positive 3x. And 3 times negative 3 is negative 9. So we've distributed on top. We keep the bottom, x minus 3, x plus 4. and then combine like terms, right? X and 3x is 4x, and 4 and minus 9, 4 and minus 9 is minus 5. So you got 4x minus 5 on top, and x minus 3, x plus 4 on bottom. Now that cannot really be simplified any further. I mean, if you wanted to, you could FOIL out the bottom, but there's no point in FOILing out the bottom. That's just a lot of extra work, and it doesn't help at all. All right, so I think we're going to stop right there with adding fractions. We'll pick up with a few more problems in the next video. We don't want to make these videos too long.